All right. Let's just get right to work here. So we want to find all the stuff using the derivatives. So we're going to find f prime. F prime of x is going to use the product rule. And the product rule says derive the first, which is 1, times the second, plus leave the first, derive the second. But when you derive e to a power, and this is something a lot of kids missed, you get the same thing times the derivative of the exponent. Okay? Yeah, a lot of kids miss that. When you derive an exponential thing, it's the same thing. It's ln to the base, but ln of e here would just be 1, right? So technically there's an ln of e floating around here times e to the negative x times negative 1, right? That's what that really is. But ln of e is just 1. Then you got to remember to multiply by the derivative of that exponent. Okay? So we're going to simplify this. That's e to the negative x minus x e to the negative x. Okay? And like I said, I know I didn't ask for the second derivative stuff, or the first derivative stuff, I mean. Let's just find it, just in case. Okay? So we want to know where this is equal to 0, where it's undefined. Well, the way you do that is you factor. The whole point of factoring is it turns into multiplication, and the only way to get 0 is if one of the things is 0. That's your multiple. One of the factors is 0. So either we need e to the negative x to be 0, or we need 1 minus x to be 0. One of those things has to happen for that product to equal 0. E to the negative x is never, ever 0. E to a power is never 0. 1 minus x is 0 when x is 1. Okay? So our first derivative number line, which I'm going to drop over here, the only number going on there is a 1. And if you plug a number less than 1 in, like negative 10, okay, check this out. You get e to the negative 10 times 1 minus negative 10. E to a power is always positive, times 11, positive. This is positive. This graph is increasing. Okay? 1's not a double root, so I expect it to change sign. If you plug in a positive, you're going to get a positive times a negative. So it's decreasing. Which means there's a relative maximum at, what was my function? Plug in 1 over e. So 1 comma. Cool? So if that had been a first derivative question, that's what we'd land on. Okay. But it wasn't. It was a second derivative question. So our first derivative, we said, was e to the negative x minus x e to the negative x. So we got to drive that again if we want to find the concavity information. So our second derivative, again, so that first thing is just e to a power. The derivative of e to a power is e to the very same thing times the derivative of that exponent, which is just negative 1. Minus, we're going to do the product rule, and anytime you do the product rule, if it's attached to other stuff, put it in parentheses. So we're going to do the product rule for this piece here, but it's attached to some other stuff with a plus or minus out front. Put it in parentheses so you know, it's the quantity of that derivative. All right. So when we derive that, we derive x, and we get 1 times the second plus leave x, derive the second, and again, that gives us that. Okay, and maybe that looks scary initially, I guess. There's a lot going on there. But if you simplify and distribute and don't lose your head about this, you get that. You get that. There's a negative and another negative, make that a plus. You get that. There's this negative here, right, which is going to make that negative, but there's this negative here, which is they're going to combine. Okay? And look, if I'm giving you something to do by hand, this should simplify down so we can factor it. Do you see how every single one of these terms has negative e to the negative x? We can factor that out, okay? But before we do that, we can combine these two things because they're the same thing. Like if you have negative x minus x, let me make sure we're okay with this. If you had negative x minus x, everybody should be able to tell me that's negative 2x. So if you have negative e to the x minus e to the negative x, yeah, there you go, negative theta. Yeah. Negative e to the negative x minus e to the negative x, yeah, is negative 2 e to the negative x plus x e to the negative x. And we want to know where that's 0. And the whole way we're going to find out where something's 0 is we're going to factor it, man. We can take out e to the negative x. And if you do that, you get negative 2 plus x in here. And really, like a better way to write that, how you're used to seeing it, is that. They're the same thing. So what number is going on my number line? Just positive 2, right? E to a power, never ever 0. So when I make my second derivative number line, which I'm labeling as my second derivative number line, I'm putting a 2 on here. Okay? If I plug in a negative value, like not negative, like 0, whatever, we're going to get a negative answer. So this is negative back here, which means this is concave down. If you plug 0 in, you get e to the 0 times 0 minus 2. That's 1 times negative 2. Okay? If you plug in a positive, like 6, you're going to get e to the negative 6 times 6 minus 2. Again, e to a power is always positive, right? E to the negative 6 really means 1 divided by e to the 6th. Now that's a small number, but it's definitely positive, okay? Yeah, a negative exponent doesn't make it negative. It finds the reciprocal of it. It flips it, okay? Cool. The only way that could be negative is if there was a negative out front of the whole thing, like negative e to something, okay? So, by the way, this is positive, which means concave up. So we're going to list all of our information out. We're going to have concave up from 2 to infinity. We're going to have concave down from negative infinity to 2. And we're going to have a point of inflection when x is 2 because the second derivative is changing sign. Okay? And you want to find the y value there, so we're going to plug 2 into, what was it? Yeah, I forget what it was already. Where is it? All the way up here? Goodness gracious, look at all this work. xe to the negative x. So we're going to have 2e to the negative second, which is fine, but I usually don't like negative exponents in my final answers. That's that. Cool? And again, I don't know how you feel about graphing something like this. Let's think about this. That right there is the same thing as that. Like e to the negative x just puts e to the x down in that denominator, okay? So again, we want to think about the end behavior, the x-intercepts, the y-intercepts, and the vertical asymptotes. 4 things really give us the shape of a graph for the most part. All right? Let's think about the end behavior. If x gets really big, if x goes to infinity, the top x is going to get big. But e to the x is going to get huger. It's not a word, okay, right? And so a number that's big divided by a number that's ridiculously gigantic, where's that going to go? It has to go to 0. So as x goes to infinity, this graph goes to 0. That's a horizontal asymptote. But then you got to worry about the other side. If x goes to negative infinity, the top is going to get negative but big. E to a huge negative a number is really a super tiny number, but positive. So I have a huge negative number divided by a very tiny number. What kind of number is that going to be? A huge, big negative number. So this is going to negative infinity. It's going to get bigger and bigger and bigger. So here's what that tells me about my graph right away. Is that on this side, it has to be headed down. And on this side, it has to be flat. Okay? I know it's positive because x times the power when x is positive is positive. What makes this thing 0? What makes the top 0? Yeah. What x value do you plug into x so that it's 0? This is so easy. I don't know, maybe it's too easy. It's just 0. If you put 0 into there, you're going to get 0, man. Okay? If you put 0 into that function, you get 0 divided by e to the 0. E to 0 is 1. Yeah. 0. Okay? Vertical asymptotes happen when the denominator is 0. But e to the x never 0. So this is what this graph does. It has to start down here. It has to be flat over here, and it has to go through that point. It's going to go like this. Through. It has to go through, not bounce. It has to go through it. But then it has to go down to that flat part. What do we start out as? We start out as concave down, and it changes to concave up, which is exactly what my number line told me way up here. It changes to 2. So right here where it changes concavity has to be 2. Okay?